So let's get started on our lesson now. Today we're going to talk about lesson 9.3, day 1, and we're going to talk about relative frequency, two-way tables, that kind of thing. So let's get started. So first things first, we're going to look at what does the word frequency mean? So in a math class, the word frequency would mean the number of times something happens. So how about relative frequency? What are they talking about when they say relative frequency? Well, that's the number of times something occurs out of the total in an experiment. So we're doing experimental probability here. We're making tables and seeing how many times something happens. And they say find the relative frequency. It's sort of like when you guys take a test and you have how many right out of the total and you find a percent. It's the same thing. It's still writing a fraction and you can convert it to a decimal and even a percent. Okay, so the word for relative frequency is finding out how many times something happens out of the total. Okay, now, um, what about two-way table? Well, you guys are familiar with tables. We've talked about tables so far, right? We know that tables can go this way, x's and y's, and we know that tables can go horizontally, x's and y's, right? It's the same thing. The only difference is instead of just having two columns like this, we're going to have three columns and then a total over here. And we'll have two columns this way and a total over here. And the whole point of all this is to compare the data to make decisions. So let's take a look at what I mean by that. So here's a two-way table. We're actually going to make a two-way table from this data right here. But this is what they would look like. Okay, so we have a couple different elements over here, some data over here, and then totals. This is what a two-way table looks like, right? All right, so how do we make a two-way table? So let's read the information they give us first. It says a poll of 120 residents. That means a poll means people that you ask. When you ask people questions and then you get your answers, that's a poll, okay? So a poll is the questions were asked out of 120 people. So in other words, this is the total people that they talked to. The total. And I say total because there's a total number of people who ride bikes. There's a total number of people that don't ride bikes. There's a total number of people who go to the farmer's market. And there's a total number of people that don't go to the farmer's market. But all of them put together is the whole poll itself. So that's why 120 has to go here. So when they give you the total, you write it right there. Next, 40% own bikes. So 40% of this number right here own bikes. So we find the section that says bikes. The total number of people that own bikes, we're not worried about whether they shop at the farmer's market or not. We're just going to find 40%. Now, 40% of something, just a reminder, in math, of means times, right? So 40% of 120 is like saying 40% times 120. Of course, we convert our percent to a decimal first, multiply these two, and we can simply grab a calculator at this point, and we say 40% of 120 means 120 times 0.4. So we know that 48 people own bikes. They didn't tell us that, but they gave us enough information to figure it out. So check, I did my 120, check, I did my 40%, and I just keep reading the problem and just keep checking them off. So of those who own a bike, 75% shop. Now, be careful. They say of those who own a bike. Of those who own a bike. So we're getting specific here now. We're not talking about of the 120 anymore. We're just talking about the bike owners. So in other words, we're going to find 75% not of 120 this time. We have to find 75% of these guys, and these guys are only 48. So for this same work that we did up here, I wouldn't use 120 because they're just talking about the bike owners this time. So this time I'd have to find 75% or 0.75 of 48 or of the bike owners because that's how many people shop at the farmer's market. So I know I have my calculator I can use, and I go 0.75 or 75% of is times 0.75, 48, and I get 36. So of all these people here, 36 people shop at the farmer's market. So here's farmer's market, here's the bike section, 36 of them shop there. 36 bike owners shop there. Okay, so let's go ahead and read the next part. All right, so it says what? So we did that part, and we keep going. Let me get rid of some of this mess here. So of those who do not own a bike. Okay, so now we're right away I go and I find the part that says no bike. Of those who do not own a bike. Well, how many people don't own a bike? Because we got to find 25% of them. Because that's how many people shop at the farmer's market here, right? So what do I do? Well, if this is the total of the totals, you know you have to add 48 plus some number to equal 120. These two add up to equal the total. These two add up to equal these total. These two add up to equal this. So there's two always being added up to equal the third in a two-way table. Let me say that again. There's two always being added up to equal the third in a two-way table. So what would I do to get this missing number here because I need it? To get this number over here, well, I would take 120 and I would subtract 48 because that's how I'd figure out 48 plus what is 120, correct? Okay, and yes, we can just grab our calculators. Either way is fine. I go 120 minus 48, and I get 72. Now, I can go back and do this part right here. Again, sometimes they don't give me the number, but they give me what I need to find the number, right? They always give me enough to find what's missing. So of those who do not own a bike, that's 72, I figured that out, 25% shop at the farmer's market. So I'm going to find 25% of, or 0.25 times 72 this time. And I take my calculator. And I already got 72 in my calculator, so I just go times 0.25. And I get 18. So of those who do not own a bike, I'm in the no bike section, 25% or 18 shop at the farmer's market. So I go farmer's market, no farmer's market, 18 goes here. Now I actually have everything I need to fill this table in. Believe it or not, we're missing 4 spaces, but you can fill it in. In fact, I want you to pause the video right now and see if you can fill this table in. Let's check your answer. So the answer was, did you put a 12 here, a 54 here, a 54 here, and a 66 here? If you didn't, let's see how to do it. Well, remember, these two add up to equal this. So to get this 12 in there, I'd have to take 48, or my total, minus the other add-in, the number you add together to get it. And that's where I get my 12 from, right? These two add up to equal this. So to get 74 down there, and those of you that did it correctly, you know that you just took 72 minus 18. You can borrow. Yes, you can use your calculators. And that's how we get 54 here. How about these numbers down here? Well, these two add up to this number down here, so you simply add those two, right? 6 plus 8 is 14. Carry the 1, we get 54 there. How to get this number here? There's 2 ways. You can just add these two or subtract these two. You should get that. That's a great way to check your answer, isn't it? If I add 54 and 66, do I get 120? If I add 48 and 72, do I get 120? You should get, this should add up to equal this. That's a quick way to check to see if you did this two-way table correctly. All right, so let's take a look at this next problem. So we're using a two-way table again, and it says Sujin counted the vehicles in the school parking lot and recorded the data. What percent of vehicles parked after school were trucks? So we have to know where to get our total from. Okay, so when you guys see the word truck, right, you might be thinking, do these guys' trucks go this way, right? And you see the word parked after school goes this way. So there's a question. Should I use 25 as my total or 20 as my total? Let's see. Let's read the question and figure out how I would know that on the quiz. So it says, what percent of what? Vehicles parked after school. That's where your total comes from. So you should focus on after school and get your total from here and not from here for this question. There are questions where you would get your total from here, but not this time. Why? Because of the way the question reads. It says, what percent of, in other words, get my total from here, not from, it doesn't say, what percent of truck owners parked after school? It says, what percent of vehicles who parked after school were trucks? So that's where you get your total from. Now, were trucks? Well, were trucks. Let's see here. How many after school were trucks? 6 after school were trucks, right? So in other words, I have 6 out of 20. That is my relative frequency, right? Number of times something occurred out of the total. Okay, so 6 out of 20. Or in other words, I can take my calculator and go 6 divided by 20. All fractions are division problems. And you can say that 30% of the vehicles parked after school were trucks. Now, here's another two-way table. I want you guys to pause and read the question to yourself. And if you can answer it, go ahead. Otherwise, just unpause when you're done reading the question. So, it looks like they threw another word at us, didn't they? Conditional relative frequency. And that's basically the same thing that we've been doing. The only difference is we're trying to see if something well, we're just being a little more specific. Let me just put it that way. Okay, let me explain. So let's go ahead and do this problem. What's the conditional relative frequency? Again, you're just finding a percent that a driver is female given that the vehicle is a car. So given that the vehicle is a car is our total. So I go and I look at all cars. I don't get my total from females. I get my total from cars this time because of the question. Okay. So what's the relative frequency that the driver is female? So I take 25 because there's 25 females of all the cars. I don't do 25 females or 25 cars of all the females. So let me erase X. I might be confusing some of you here. So again, let me back up. Where do I get my total from? Is it the 32 or the 33? What's a conditional relative frequency that a driver is female given that the vehicle is a car? So is a car, okay, I'm talking about cars. That's why I go this way to get my total and not this way this time. You could get your total this way from a different question, not this one. So 25 cars out of 33 females. I take my calculator and I do 25 divided by 33 and I get about, it rounds to 75%. Okay, back to that word conditional relative frequency. So we know relative frequency is how many times something happens out of a total. When they slap that fancy word conditional in there, they're saying, well, let's just look at specifically a specific group, either all the car owners or all the females, instead of just always using the total every time. That's what that word conditional means. Okay, but don't let that hang you up. You're just finding amount out of total and dividing. That's all these problems are. So let's take a look at another one. I want you guys to pause this video and just read that top 2 sentences to yourself. So you should have read a new word, association, right? So let me explain what that means. Is there an association between? What they're talking about there when they ask if there's an association is this group of people more likely to do something than another group? That's what they mean by an association. Another way of saying that is there a relationship between this group of people and that group of people? So, for example, is there a relationship between people who exercise and living longer? Is there an association between people who live longer and exercise? So that's what an association or relation means. And so these questions here, it's like the last couple that we've done. The only difference is you have to find how many people do something out of the total, and then you have to find How many people do something out of a specific group? And that's what that word conditional relative frequency means. Okay, so let's do this one step at a time and take a look and see what I mean by that. All right, so first things first, we're finding if there's an association. You have to find the percent out of everybody. So an association, or is there a relation? Question means you're going to use this for one of them. You're going to use a total for one. Okay, so we're going to find percent of students that have chores. So how many have chores? Right here. These guys have chores. Some have a curfew, some don't, but total people that have chores is 20 out of everybody is 100, and you could divide that, but hopefully you remember that percent means out of 100, so it's already 20%. Okay, if you divide it, you got 0.2, move the decimal 2 times, 20%. So that's how many people have chores. You take the total over the total. That's step one for association questions. Find percent out of everybody. Now, how do I know if there's an association? Now we're going to look at a specific group. We're going to find a conditional relative frequency for a specific group. It says what percent of total students who have a curfew? That's where we get our total. Total of what? Total who have a curfew. So I have to look at curfew now. Everybody that has a curfew, that's where I get my total from this time. My total is 32. What percent of students who have a curfew also have chores? So of those people, 16 have chores. And if you did 16 divided by 32, some of you know that 16 is half of 32 is 50%. So let's back up. Is there an association? Find how many people out of everybody do it. Then find your conditional relative frequency. How many out of this specific group do it? And what we do next is we compare these two percentages. If these percentages are very close to each other, then there's no association between having a curfew and doing chores. However, if these numbers are different, if these percentages are different, then there is an association between having a curfew and having chores. So let me explain. So normally 20% of people do chores, but if you just look at people that have a curfew, 50% of them, in other words, more of them do chores than the entire group together, including them, which means if you have a curfew, you're more likely to do chores than if you don't. There's an association. Now, if these percentages happen to be the same, then you would say, no, there's no association. And some of you are going to get that on your quiz. Some of you will get this situation where the percents are different. And on your quiz, the answer will be, yes, there's an association because of these percents are different. But some of you will get the same percents. And your answer will be, no, there's no association. This specific group, this conditional relative frequency is the same as everybody else. So now it doesn't matter if you got a curfew or not. You have the same amount of chores as everybody else. Okay, so we're looking to see if the percentages are different or not to decide if there is an association or relationship between two things. All right, and the last type of question we need to know is just filling in a two-way table, and we already did this. I want you guys to pause this though and do one last time before we end this video. Pause the video now and fill this in. All right, so how do we do this? These two add up to equal this. So I got 7 plus 3 is 10. Carry my 1, 6, 7, or just take a calculator, add those two together, okay? These two add up to equal this over here. So what do I do? Then I can just subtract these two, right? I can go 78, take away 57, and I see I get a difference of what, 21 right there, okay? This is how we fill this table in. But on your quiz, you're going to see a question like this where all they want is where the question mark be. The question mark might be here, might be here, might be here, it might be here. So for this particular problem, when you see that question mark, all you have to do is give this answer for this one. That's all you got to do. So the answer for this is I take these two, subtract them, and I get my answer. All right. Okay, I hope that helped you guys out. We will see you all soon.